Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximise, minimise and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Welcome back to part 2 of the Azure Virtual Training Day for Data Fundamentals. So today we're going to take a look at Module 3, where we're going to explore some of the non-relational data services in Azure, and Module 4, where we're going to have a look at some of the data analytics solutions in Azure. Now, in Module 3, we're going to take a look at some of the non-relational data services in Azure, such as Azure Cosmos DB, Azure Storage Account. We're going to also have a look at how to provision and deploy those services in Azure, as well as how to query non-relational data in Azure. So let's get started with Module 3. Lesson 1, explore non-relational data offerings in Azure. So we'll start with Azure Table Storage. Now, Azure Table Storage implements the NoSQL key value model. So in this model, the data for an item is stored as a set of fields, and the item is identified by a unique key. Now, Azure Table Storage is a scalable key value store held in Azure. So you create a table using an Azure Storage account. In an Azure Table Storage table, items are referred to as rows, and the fields are known as columns. But don't let this terminology confuse you by thinking that it's the same as a table in a relational database, because Azure Table Storage allows you to store semi-structured data. So all rows in a table must have a key, but apart from that, the columns in each row can vary. So unlike the traditional relational databases, Azure Table Storage tables have no concept of relationships, store procedures, secondary indexes, or foreign keys. Now, data will usually be denormalized, with each row holding the entire data for a logical entity. So, for example, a table holding customer information might store the first name, last name, one or more of their telephone numbers and addresses for that customer. And the number of fields in each row can be different depending on, the number of telephone numbers or addresses that particular customer might have. Now, in the relational database, this information would be split across multiple rows and several tables. However, in an Azure Table Storage table, this isn't. So we're able to get much faster access to the details of a customer because all the data for that customer is available in a single row. So you don't have to perform any complex joins across tables and figuring out relationships between tables. Now, to help ensure even faster access, Azure Table Storage splits the table into partitions. And partitioning is a mechanism used to group related rows based on a common partition key. So the rows that share the same partition key will be stored together. Now, the key in Azure Table Storage table is that there's two elements you need to be aware of. So there's a partition key, which identifies the partition that contains the row, and the row key, which uniquely identifies each row in the same partition. And items in the same partition are stored in the same row key order. Azure Table Storage is commonly used for storing terabytes of structured data capable of serving web-scale applications. So some of these might be, for example, product catalogs for an e-commerce website or application, customer information where the data can be quickly identified and ordered by a composite key. So in the case of the product catalog, the partition key could be the product category, so like footwear, for example, and the row key, which identifies a specific product in that category, could be something like mountain boots. Now, storing data sets without requiring those complex joins, foreign keys, or store procedures in this denormalized ways enables us to have much faster access to our data using Azure Table Storage, which means Azure Table Storage is perfect for things like IoT systems, where we need to capture data very, very quickly and store it immediately. And so if we're talking about IoT device sensor data, each device could have its own partition, and the data could then be ordered by the date and time which those sensor points were collected. Now, Azure Blob Storage is a service that enables you to store massive amounts of unstructured data, or blobs, in Azure. So just like Azure Table Storage, you would create a blob storage account under an Azure Storage account. Now, Azure currently supports 3 different types of blobs. So there is block blobs, page blobs, and append blobs. A block blob is handled as a set of blocks. So each block can vary in size up to 100 megabytes. A block blob can contain up to 50,000 blocks, giving you a maximum size of 4.7 terabytes. So the block blob is the smallest amount of data that can be read or written as an individual unit. And block blobs are used to store discrete, large binary objects that are changed very infrequently. Now, page blobs is organized as a collection of fixed size 512 bytes of pages. And so a page blob is optimized to store random read and write operations. You can fetch and store data for a single page if you need it. A page blob can hold up to 8 terabytes of data. And so Azure actually uses page blob to implement the virtual disk storage for Azure virtual machines. An append blob is essentially a block blob, but optimized to support append operations. So you can add blocks to the end of an append blob. So updating or deleting existing blob isn't supported in append blobs, and each block can vary in size, up to 4 megabytes. Now, the maximum size of an append blob is just over 195 gigabytes. Inside an Azure Storage account, for blob storage, you would typically create blobs inside containers. So a container provides a way for you to group related blobs together, and you can organize blobs in a hierarchy of folders, similar to the way that you would organize files on your file system or disk. And you can also control who gets to read and write the blobs inside that container, or who gets to read and write the container itself. Now, blob storage provides 3 access tiers to help you balance that access latency and storage costs. So the first being the hot tier, which is enabled by default. So you use this tier for blobs that are accessed frequently. So the blob data is stored on high performance media. The next tier is the cool tier. So this tier has lower performance and incurs reduced storage charges compared to the hot tier. So you use the cool tier for data that is accessed not as frequently. So it's commonly for newly created blobs that needs to be accessed initially quite frequently. So you store that in the hot tier, but as time passes, you don't need to access it as frequently. And so in this kind of situation, you can create the blob in hot tier first and then slowly migrate it to a cool tier later on. And this will help you save on some of those storage costs. Now, the third tier is the archive tier. So the archive tier provides the lowest storage costs, but it has very, very high latency, because the archive tier is essentially intended for any historical data that you want to keep, that you don't want to lose, but you're not going to ever really access it. So blobs in the archive tier are effectively stored in an offline state. So typical reading for typical reading latency for hot and cold tiers might range between a few milliseconds, but for an archive tier, this can take up to hours for it to become available. So if you want to retrieve a blob from archive tier, you must actually first rehydrate it. By rehydrating, I mean you need to essentially upgrade that blob into a hot or a cold tier before you can then actually access that blob. So some of the common use cases for Azure Blob Storage includes storing images or documents that you are maybe serving directly to a browser, storing files for distributed access, storing video and audio files that you want to stream, storing data for backup, restore, disaster recovery, or archiving purposes, and storing data that is used for analysis for both on-premises or cloud environments. To ensure availability, Azure Blob Storage also provides redundancy. So your blobs are always replicated 3 times in the region in which you created the Azure storage account, but you can also select geo redundancy, which would replicate your data to a secondary region also 3 times, but this comes at an additional cost. Now, other features that Azure Blob Storage supports includes versioning, so that you can maintain and restore earlier versions of a blob. There is also a feature called soft delete. So if you turn on soft delete, this will enable you to recover any blob that has been deleted or overridden or removed by accident or by mistake. There's also a feature called snapshots. So a snapshot is a read-only version of a blob at a particular point in time. And there's a feature called change feed. So the change feed for a blob provides an ordered read-only record of the updates made to a blob. So you can use the change feed to monitor changes and perform operations. Now, many on-premises systems comprising a network of in-house computers make use of file shares. So a file share enables you to store a file on one computer and grant access to that file to users and applications running on other computers. So this strategy works quite well for computers using the same local area network, but it doesn't scale as well for users who might be located at different sites or if that number of users increases. Now, Azure File Storage enables you to create file shares in the cloud in Azure, and you can then access these file shares virtually from anywhere as long as you have an internet connection. So Azure File Storage exposes file shares using the SMB 3.0 protocol, or the server message block protocol. This is the same file sharing protocol that's used by many existing file shares on premises. Now, that means what you can do is you can actually migrate your file shares to Azure, to the cloud, without having to modify a lot of your applications which access these file shares. So you can also control the access to these file shares in Azure File Storage through authentication and authorization services that's available through the Azure Active Directory domain services. Again, just like blob storage, you create an Azure File Storage within an Azure Storage account, and Azure File Storage enables you to share up to 100 terabytes of data in a single storage account. Once you've created your storage account, you can upload files to Azure File Storage either through the Azure portal, or you can use tools like the AZ copy utility. You can also use the Azure File Sync servers to synchronize any of your local file shares up with the Azure File Storage. So Azure File Storage is a fully managed service. Your shared data is replicated locally within the region, but it can also be geo-replicated to a secondary region. And all the data is encrypted at rest. And so you can enable encryption for data in transit as well between your Azure file storage and maybe some of your applications that are communicating with the file share. Now, relational databases store data in relational tables, but sometimes the structure imposed by this model can be a bit too rigid, and often this leads to poor performance unless you have a lot of time to really fine-tune some of those implementation problems. So other models, collectively known as NoSQL databases, exist to help overcome some of those issues. Now, these models store data in other types of structures, such as documents, graphs, key value stores, and column family stores. Azure Cosmos DB is a multi-model NoSQL database management system. So Azure Cosmos DB is able to manage data as a partitioned set of documents. Now, a document is a collection of fields, typically identified by a key. The fields in these documents can vary, and a field can contain other child documents. Now, many of these document databases use a format called JSON to represent the document structure. So in this format, the fields in the document will be enclosed in those curly braces, and then each field is prefixed by a name. Now, a document can actually hold up to 2 megabytes of data, including small binary objects. If you do need to store larger blobs as part of a document, you can use Azure Blob Storage and then add a reference to that blob inside your document. Now, documents in a Azure Cosmos DB database are organized into containers. So the documents in the container are grouped together into partitions. A partition holds a set of documents that share a common partition key. So you designate one of the fields in your document as the partition key. Now you need to select this partition key quite carefully because it will relate all your documents together. So this approach will help reduce the amount of I/O or input and output operations that a query might need to perform to retrieve a set of documents for a particular entity. Now, in a document database, for example, if we are looking at an e-commerce system and we are recording the details of customers and the orders that they've placed, we could say partition the data by customer ID and then store the customer and order details for each customer in the same partition, which means to find the information and orders for a single customer, we simply need to query that one partition. Now, it seems like that there is a bit of similarity between Azure Cosmos DB container and a table in Azure Table Storage in that data is partitioned, so documents and in Cosmos DB and rows in a table, and that they're both identified by some unique ID within the partition, but that's sort of where the similarity ends. So unlike Azure Table Storage, documents in a Cosmos DB partition aren't actually sorted by ID. Instead, Azure Cosmos DB maintains a separate index. So this index contains not only the document IDs, but it also tracks the value of every other field or the fields inside that document. And this index is created and maintained automatically so that you can use it to perform queries, such as trying to query for a particular field inside those documents in your container without having to scan through the entire partition or all the documents in that container to find the data that you're looking for. Now, Cosmos DB provides a couple of APIs to allow you to access the documents, and it also provides support for other NoSQL database management systems through these APIs. So these APIs are the Table API, the MongoDB API, the Cassandra API, the Gremlin API, and the Table API is essentially an interface that allows you to use the Azure Table Storage API to store and retrieve documents. The purpose of having this API is really to allow you to switch between table storage to Cosmos DB without requiring you to modify any of your existing applications. The MongoDB API is used to support any MongoDB databases that you might already be using for your applications. So MongoDB is another well-known document database. It's got their own programmatic interface, and many organizations actually use it on their premises within the organization. So you can use the MongoDB API for Cosmos DB to enable a MongoDB application to run against your Azure Cosmos DB without having to make any changes to your applications, so that you can migrate the data from your MongoDB database to a Cosmos DB database running inside of Azure and continue to use the same applications to access the data inside Cosmos. Now, the Cassandra API is used to support Cassandra, which is a column family database management system. So this is another database management system that, again, a lot of organizations run on premises. And the Cassandra API for Cosmos provides a Cassandra-like programmatic interface for Cosmos DB. So Cassandra API requests are mapped to Cosmos DB document requests. Just like the MongoDB DB API, the primary purpose of the Cassandra API is really to enable you to quickly migrate any of your existing Cassandra databases and applications without having to make many changes to it to Cosmos DB. And the Gremlin API, well, the Gremlin API implements a graph database interface to Azure Cosmos DB. So again, a graph is a collection of data objects with directed relationships, and data which is held in a set of documents in Azure Cosmos DB can actually be queried using the Gremlin API, which allows you to perform those graph-like queries over your data that's held inside your Azure Cosmos DB. Now, the main use of Table, MongoDB, and the Cassandra APIs is really to support any of your existing applications that are already using these kind of data stores as their backend, as their data tier. So if you're building out any new applications and databases, you should really use the SQL API or the Gremlin API. So Azure Cosmos DB is very suitable for some of these scenarios. So if we're talking about retail and marketing, Microsoft actually uses Azure Cosmos DB for our own e-commerce platforms that run as part of the Windows Store and Xbox Live. And Azure Cosmos DB can actually be used quite extensively in the retail industry to, for example, store catalog data or for event sourcing in order processing pipelines. In the gaming industry, the database tier is quite a crucial component for gaming applications. So modern games perform graphical processing on mobile and console clients, but they typically rely on cloud services to deliver these customized and personalized contents like in-game stats, social media integration, and high score leaderboards. Games often require single millisecond latencies for reads and writes to provide that engaging in-game experience. And so a game database needs to be very fast, and it needs to be able to handle massive spikes in request rates, especially during new game launches or new feature launches and updates. Azure Cosmos DB is also able to support IoT systems and devices. So in IoT systems, typically a lot of data is ingested very, very frequently, because these data are being generated on a second-by-second basis. And so using Azure Cosmos DB, we're able to ingest and store this data very, very quickly. So then this data can be used by analytic services like Azure Machine Learning or Azure HD Insight or Power BI to then run analytics workloads on top of it. Additionally, you can also process the data in real time by triggering an Azure function to help filter and trigger and to process some of that data as well as it comes into your Azure Cosmos DB database. Lesson 2, explore provisioning and deploying non-relational data services in Azure. Now, there are a couple of ways we can provision Azure Cosmos DB. We can provision Azure Cosmos DB through the Azure portal, which we've already seen how we can do that with the Azure SQL database. So it's a similar approach using the Azure portal. We can also provision Azure Cosmos DB through the Azure command line interface or the Azure CLI. So typically you use the Azure CLI to execute CLI commands through either your command line prompt or through the Azure Cloud Shell. So CLI is suitable if you need to automate service creation. You can store CLI commands and scripts, and you can run these scripts programmatically. And CLI can actually run on Windows, Mac OS, and Linux computers. Azure PowerShell is also another way you can provision an Azure Cosmos DB. So if you're familiar with PowerShell, this is kind of the alternative to Azure CLI. So again, you can use PowerShell commands to script and automate tasks. You can also use PowerShell to create and manage Azure resources just like CLI. And similar to CLI, it's also supported by Windows, Mac OS, and Linux. You can also use Azure Resource Manager templates or ARM templates to execute your deployments. Now, ARM templates is essentially a declaration of your infrastructure and its configuration and set up as code, so as JSON code. So this code that's formatted in JSON can then be used to deploy your Azure resources and provision your Azure resources like an Azure Cosmos DB. So let's take a look at how we can use the Azure portal to provision an Azure Cosmos DB database. So I'm on my Azure portal now, and I'm going to provision an Azure Cosmos DB account. Then I'm going to create a database inside the Azure Cosmos DB account. And then inside that database, I'm going to spin up a container for my documents. So again, I'm just going to look up Cosmos DB from my search bar. I'm going to click into it, and I'm going to go add. Now, I need to provide a couple of configuration details, just like the Azure SQL database that we set up earlier. So I'm going to start with the basics. I need to choose the subscription, which this Azure Cosmos DB will be deployed to. I also need to put it inside a resource group. So I'm going to look up the demo one that I set up earlier. Now, I also need to give my Azure Cosmos DB account a name. This name needs to be unique. So I'm just going to say Cosmos and enter some random numbers. The API section is where you can choose what kind of API queries we want to use against our Azure Cosmos DB databases. So if I open up this drop-down, we can see that the core SQL API is supported, the MongoDB API, Cassandra, Table Storage API, and the Gremlin one. So I'm going to just pick the core SQL API. Now I'm going to leave notebooks switch off. It's still in preview. And for location, this is where I'm going to pick which Azure region I want to deploy my Azure Cosmos DB databases to. So I'm going to go and find East US because that's what I've been provisioning all my services so far. And then in capacity mode, you get to pick between provision throughput and serverless. Now, the difference between the two is provision throughput is essentially dedicated resources for your Cosmos DB to run. Serverless is essentially resources that will be provisioned to you when you need it. And so it's not constantly dedicated to you. So if you've got very light workloads or you're doing dev test scenarios, you can use a serverless option. However, if we're talking about production workloads, you should really consider using the provisioned throughput option because this will give you dedicated resources for your Cosmos DB databases. We can also apply a free tier discount to our Azure Cosmos DB account. Now, this free tier can only be enabled once per account per subscription, and you'll get 400 RUs per second and 5 gigabytes of storage for free. And so RUs means request units, and request units, you can think of it like the computes and a whole bunch of other resources that is needed to actually run your Cosmos DB databases. And this actually increases as the throughput for your Azure Cosmos DB database requirements increases as well. And so if we apply this discount, we actually save around $24 a month. But I'm not going to apply it because I've actually already created an Azure Cosmos DB account, so it's not going to be applicable to me. I can also choose what kind of Azure Cosmos DB account this is. So is it a production one or a non-production one? I'm going to leave the non-production one because this is a demo Azure Cosmos DB. And here I can come and configure things like geo-redundancy, multi-region rights, and availability zones. So geo-redundancy, if I enabled it, this means that I'm going to replicate some of my Azure Cosmos DB databases to other regions, other Azure regions across the world. And so that means if my primary database somehow encounters some errors or a natural disaster happens, I can quickly and easily fail over to some of my other databases running in other regions that are not affected by this disaster, for example. Multi-region rights, if I enable this, it means I can actually create several master copies of my databases located in other regions around the world, other Azure regions around the world. And what that means is I can actually do write operations to multiple different nodes or databases across the Azure regions. And so if I enable multi-region rights, I can write to multiple master databases. Availability zones is all about provisioning an Azure Cosmos DB for high availability. So what that means is your Cosmos DB databases will actually be located into different availability zones, which means that they will be highly available. So if something happens to one zone, you're guaranteed that there is always going to be other running instances in some of the other zones. I'm going to disable and turn off all those features for now, just because this is a demo Cosmos DB. And I'm going to head over to the networking tab. Now, networking tab, similar to the Azure SQL database, this is where you configure the network connectivity. So we can choose from all networks, which means any networks around the world, from the internet, from Azure, from anywhere you're on premises, can access the Azure Cosmos DB. Or we can choose selected networks. So the public endpoint will allow you to only allow access to the Cosmos DB from a couple of networks, or we can select the private endpoint, which means we'll block off all public access to our Cosmos DB account. I'm going to go back and just enable all networks, and I'm going to head over to the backup policy. So backup policy is where you specify how frequently we want to make backups of our Azure Cosmos DB databases and how long we want to retain those backups for. And so you can specify that in the backup interval and the backup retention rates. Now I'm just going to leave all the default values and head to the encryption tab. So Azure Cosmos DB databases supports data encryption, and you can either use the Microsoft Service Managed Keys, managed encryption keys, or you can bring your own encryption keys to encrypt the data that is stored inside your Azure Cosmos DB databases. I'm just going to leave the Service Managed Keys because I don't have a key to provide my Cosmos DB account, and I'm going to head over to the tags section. So again, in the tag section, we can add some metadata to our Azure Cosmos DB account to provide more information about what this particular Azure Cosmos DB account is being used for. I'm not going to add any tags, and I'm just going to head over to review and create. that's going to run a small validation check just to make sure that some of my configuration details I've given it is correct and valid. And once that's passed, I can then go and create my Azure Cosmos DB account. So that's going to submit it to Azure to go and deploy my Azure Cosmos DB account for me. Now, once that has been deployed, we can then create an Azure Cosmos DB database, and then inside that database, we can create a container, which is where our documents will be located. And so because in wary of time, I've actually set up a Cosmos DB to look at. So while this one actually goes and deploys, let's have a look at a Cosmos DB that I've spun up earlier. So there you go. I have one that I've set up earlier called my DP900 Cosmos DB. So let's just go into it. And again, on the overview page, we can see some of the credentials and details about this particular Azure Cosmos DB account. So I can see, for example, where the endpoint to access my this particular Azure Cosmos DB account is, the region that it's been hosted and deployed to, and a bunch of other details as well. Now, if I go into the Data Explorer tab, this is like the Query Explorer tab that we saw in the Azure Cosmos in the Azure SQL database, but this one is for Cosmos DB specifically. So if I head into the Data Explorer tab, I can directly create some Azure Cosmos DB databases and containers from the Data Explorer. And as you can see, I've actually created a couple of databases already. So I've got one called Demo Database, and I have one called Volcano. So if we drill down into the Demo Database one, I can see that I've already got a container inside this particular database. So this container is called Demo Volcano Data. Now I can also come up here and create a new container. So I'm going to create a new container, and I need to give my container an ID. So I'm just going to call this my demo container. I need to give this container a partition key. So I'm just going to say this container's partition key will be ID for the data the document data I'm going to be uploading to this container. And the throughput is where we specify the number of RUs to provide this particular containers. And so we can see that the lowest start at 400 and the highest is 100,000 RUs we can provision for this particular container. So you can choose between manual, which means if I specify 400 RUs will be provisioned to this container, or I can pick auto scale, which means the RUs allocated for this container will automatically scale depending on our workload needs. And so I'm actually going to turn that off and go back to the smallest one. I can also configure analytical store, so I'm just going to leave that off for now, and I'm going to click OK after that. And that's going to go and then create my container for me inside my Azure Cosmos DB database. The data migration tool can be used to input data to your Azure Cosmos DB from a variety of sources. So it's available to be downloaded from GitHub, and the tool actually guides you through the process of migrating data into your Azure Cosmos DB databases. So you're prompted for the source of data inside the Azure Cosmos DB migration tool, as well as the destination, which is essentially the Azure Cosmos DB database and the container that you want to migrate the data to. So the tool can be used to either populate an existing container or create a new one if the specified container doesn't exist already. And you can also use the data migration tool to export data from an Azure Cosmos DB container to a JSON file that can be either locally hosted or hosted on Azure Blob Storage, for example. If you have a lot of data, the data migration tool can also make use of multiple concurrent threads to batch your data into chunks and then load those chunks in parallel. So let's take a look at how we can use the Azure Cosmos DB migration tool to load some data into the Azure Cosmos DB database that we just set up. So I've opened up the Azure Cosmos DB data migration tool, and this is what it looks like. I've downloaded this from GitHub, and I need to provide it a couple of information, so the source and the target information. So we come into source. Again, we can import from a couple of sources, so JSON files, MongoDB, SQL, CSV, and so on and so forth. Now I'm going to go and add a JSON file from my desktop. So I'm just going to go add files. I'm going to pick this particular Volcano data JSON file, and I'm just going to open that. Now I need to provide the target information, which is essentially my Azure Cosmos DB database to connect to and the container to import to. So I need to come and grab the Cosmos DB connection string, which means I need to go back to my Azure portal and find my Azure Cosmos DB that I set up to grab that connection string. So let's just go do that. So this is my Azure Cosmos DB account. I'm going to go into it, and I'm going to need to go and find that connection string to then be able to input into my target. So if I scroll down a little bit, and it's under keys, so I'm going to grab my connection string from keys. So if I scroll a little bit more, I can find the primary connection string. I'm just going to copy that. Now I'm going to head back to my data migration tool, and I'm just going to paste that into the connection string option. Now I also need to specify the database to connect to. So the database is, if I go back to my Azure Cosmos DB to find out the database name, I'm going to head into the Data Explorer, and I can see that it's called Demo Database. That's the one that I created earlier. So I'm just going to enter Demo Database into my data migration tool. And then I'm going to hit Verify. And this is going to check whether or not it can connect to my Azure Cosmos DB. So that connection is successful. So I'm just going to close this. And now I need to specify the collection or the container to import my JSON files to. And so earlier I created a demo container to import my JSON files to. So I'm just going to specify it's the demo container that I want to import my JSON files to. And I also need to specify the partition key for the data. So I'm just going to say ID as my partition key. And I'm going to change the throughput to match the one that I assigned the container. So I'm just going to change that to 400 RUs. And if I go next, now you can specify some of these advanced configurations as well. I'm not going to. I'm just going to hit next. And I get a summary of my configuration details for this particular data migration. Once you've checked that everything is accurate, we can simply hit import. And that is now going to start importing my JSON files up to my Azure Cosmos DB database and inside that particular container. So let's have a look at how authentication works in Azure. So when a user or application attempts to authenticate, they need to specify the domain to authenticate against. Now, Azure Active Directory will typically require the user or the application to provide some credentials, often a password, to prove their identity. It's also possible to configure multi-factor authentication to reduce the possibility that a fraudulent user with a stolen password is trying to authenticate against the service. For example, you could specify that not only does the user have to provide a password, but they also need to respond to a text or a phone message sent to their mobile device before authentication. Now, if the authentication is successful, Azure Active Directory creates an authentication token for the user or the application to use, which means when that user or application attempts to access a resource, this authentication token is passed as part of the request to the service, and the token is then used by the service to authorize the access to that resource. Now, configuring an Azure storage account will allow you to access many storage services in Azure, such as blob storage, file storage, table storage, and queue storage. We can even set up an Azure Data Lake storage through an Azure storage account. So let's take a look at how we can actually set up an Azure Data Lake storage through an Azure storage account on the Azure portal. So I'm back in my Azure portal and I'm just going to look up a storage account. I'm going to click into my storage account and ignore the previous ones that I've got. I'm going to go add. And again, I need to provide some basic credentials and other settings to create my Azure storage account. So I'm going to start with the subscription, which is going to be my internal subscription. I'm going to put it inside the same resource group as both my SQL database and my Cosmos database. I need to give my storage account a name, and this name needs to be unique, which means it needs to be a storage account name that no one has used across Azure before. And so let's just call this storage account, and I'm just going to give it a bunch of nines. Hopefully that's unique. Yes, so that's passed. Now I also need to pick the Azure region to deploy my storage account to. So I'm just going to leave the East US region. I can choose the performance level here. So do I want to create a storage account that is under the standard tier or use the premium tier? So I'm just going to leave the standard one. And under account type, this is where I can choose what kind of Azure storage account I want to set up. So general purpose V2 is actually the newest and latest version that we've got. So I'm just going to keep that as is. And under replication, this is where you can choose the redundancy options for your Azure storage account. So redundancies or replications start from LRS or locally redundant storage. This means 3 copies of your data will be replicated inside the same Azure region and the same Azure data center. Zone redundant storage means that 3 copies of your data will be replicated within the same Azure region, but they'll be distributed across the different availability zones in that region. Geo-redundant storage means 3 copies are replicated within your primary region, as well as 3 copies will be replicated and placed in a secondary Azure region. And there are other redundancy and replication methods as well. You're more than welcome to go and read up on some of the Microsoft docs on exactly how those replication works. I'm just going to go with the lowest one, so the LRS option, and then I'm going to go next to networking. So again, this is where we configure how we want to connect to our storage account. So do we want to enable all networks to be able to access our Azure storage account, or only a selected few networks, or no public access at all, and this storage account can only be accessed via a public endpoint? I'm just going to open this up to all networks. You can also define some network routing rules if you want. I'm just going to leave the default one for now. And I'm going to head into data protection. So data protection, we can do things like configure how we want to recover some of the data stored inside our storage account. So we can turn on point-in-time restores for containers. We can turn on soft delete for the blobs. We can turn on soft delete for file shares if we're using Azure File Storage. We can turn on versioning for the blobs, and we can turn on the change feed for the blobs as well. So I'm just not going to turn any of this on because this is a demo storage account, and I'm going to head into advanced. Now, in advance, we can configure some of our security settings. So do I want security transfer enabled? And I'm going to enable it. You can select the TLS version. So there is the option to pick from 1.0, 1.1 to 1.2. I'm just going to leave the default 1.2. And under blob storage, this is where you pick those tiers, those access tiers to your blob storage account. So if we enable public access, it means we can have public access to our blob storage accounts. And the access tier is where you choose whether the blob storage account will hold blobs under the hot tier or the cool tier. So I'm just going to leave these default configuration. Now, the Data Lake Storage Gen 2 section is where we want to specify whether or not we want to create this storage account as a data lake storage. And so Data Lake Storage is essentially an extension built on top of Azure Storage or Azure Blob Storage, so that there is a hierarchical file system that you need to define to store your blobs. And this is how you typically would set up a data lake in Azure. So I'm going to actually enable that because I want to set up that data lake storage. I can also come in here and I can set up my Azure file storage if I enable it. I can also set up tables and queue storage. I'm not going to do that for now, and I'm just going to go next to the tags. And again, we can add some metadata to describe exactly what type of a storage account this is. So for example, I can say this storage is a data lake, maybe. And then I'm just going to go into review and create. And it's going to run that validation check to see that I've passed all the right configurations. And once that validation test has checked out, I simply hit create. And that's going to then create my data lake storage for me. This concludes the first part of Module 3. So let's go take a 10-minute break, and then we'll come back and continue exploring non-relational data in Azure. Welcome back from the break. So now we're going to take a look at how to query non-relational data in Azure. So let's continue with Module 3. Lesson 3, Manage non-relational data stores in Azure. So when an application writes data, the change is recorded by one server and then propagated to the other servers in the cluster asynchronously. While this strategy helps to minimize latency, it can lead to inconsistencies in the data. For example, application 1 might make changes to a document, and then application 2 reads the same document. But if the application 2 retrieves the data from a different server in the cluster than what application 1 used to write to, there will be a small window of opportunity during which application 2 might see some of the old data. Now, this issue doesn't just arise from multiple applications. Inconsistencies can occur in a single application if a write is directed towards one server in the cluster. But a subsequent read operation is performed against a different server. Now, in Azure Cosmos DB, there are a couple of options that allows you to specify how inconsistencies should be handled. And these options are eventual, consistent prefix, session, bounded staleness, and strong. With eventual, this option is the least consistent. It's based on the situation that we've just described. So changes won't be lost. They'll appear eventually, but they might not appear immediately. Additionally, if an application makes several changes, some of these changes might be immediately visible, but others might be delayed. So the changes could appear out of order. With the consistent prefix option, this option ensures that changes will appear in order, although there may be a bit of a delay before they become visible. And in this period, an application might actually see some of the old data. With the session option, if an application makes a number of changes, they'll all be visible to the application and in order. Other applications may see some of the old data, although any changes will appear in order as they did for consistent prefix. Now, this form of consistency is also sometimes known as read your own write. Bounded staleness is where there's a lag between writing and then reading the updated data. So you typically specify this staleness as a period of time or a sort of window or number of previous versions where this data may be inconsistent. And then with the strong option, this is where all writes are only visible to the client after the changes have been confirmed successfully written to all the replicas. And so this option means that sometimes when your applications are trying to read from some of the replicas, it might be unavailable because some of these changes might actually be trying to be made so that when your application does read the data, it's all consistent. And so eventual consistency provides the lowest latency and the least consistency, while strong consistency results in the highest latency, but it also provides the greatest consistency. And so you should always choose a consistency level or option that balances that performance and requirements that your applications need. Now, although Azure Cosmos DB is described as a NoSQL database management system, the SQL API, the core SQL API, actually enables you to run SQL-like queries against your Cosmos database. So these queries, again, use very similar syntax to SQL, but there are some differences. This is because the data that we're trying to query against your Cosmos DB is actually structured as documents rather than tables. So if we were to use the core SQL API to query documents, the Cosmos DB SQL API supports a dialect of SQL for querying documents using select statements, much similar to the select statements in the relational database. And the SQL API actually returns results in the form of JSON documents rather than the results that you typically see with, or the table rows that you typically see with relational databases. And all these queries must be executed in the context of a single container. Now, just to understand a bit of the core SQL API, we have a select clause. So the select clause starts with the select keyword, followed by a comma-separated list of properties to return. The star usually means all the properties in the document. The from clause, so this clause starts with the keyword from, followed by an identifier, which represents the source of the records. And you can usually use an alias as well to identify where the source is coming from. So in the relational database query, that from clause would typically contain the table name. Now, using the SQL API for Cosmos DB, all the queries are limited to the scope of a container. So the identifier after the from clause would represent the name of the container. The where clause is again another optional clause. So it starts with the keyword where, followed by one or more logical conditions that must be satisfied by a document returned by the query. So you can use the where clause to filter results of some of your Cosmos DB queries. And the order by clause is again an optional clause. So it starts with the phrase order by, followed by one or more properties used to order the output result set. Now, a query can also contain a join clause. So in a relational database management system like Azure SQL database, the join clause is used to connect data from different tables together. In the core SQL API, you typically use the join clause to connect fields in the document with fields in a sub-document that is part of the same document. You can't perform join operations or queries across different documents like you would with the tables in a relational database. So let's go back to our Azure Cosmos DB and our Azure portal, where we've actually imported some of that data into our Cosmos DB, and let's have a look at how we can query some of that data using the core SQL API. So I'm back in my Azure Cosmos DB account. I'm going to go and navigate to that database and container that I created earlier by going to Data Explorer. Now this is going to open up some of the databases that I've created. So the demo database, if I open that up, there's my demo container that I created earlier. So I can come in here and hover over these three buttons, and I'm just going to click and go create a new SQL query. Now by default, it's given me this select all from container statement. So if I executed this, it's actually going to retrieve all the documents that's currently inside this particular container. So I can quickly try and run this. I'll highlight it and execute selection. And as you can see, all the documents inside this container is returned. Now, that's not a very interesting query, so let's do something with it. I know, for example, that this is Volcano data because that's what I imported earlier. So I can drill down into here and look into some of this data with the select all from container statement. So let's have a look at something even more interesting. So if I do a select all from the container and I set a where condition, let me just minimize this a little bit. I'll set a where condition, and I know that by looking at this data, there are some fields in my document. So there's a field, for example, like country. So if I wanted to say, for example, specify the country field to be, let's say, Japan. And hit execute. Now, if I pull this up again, and let me just minimize this so that I have more space. I pull this up, now I'm getting all the documents where it contains volcanoes that are located in Japan. So as you can see, I'm still getting a lot of documents back from my container and my query. So let's filter it a little bit more. Now, another field is elevation. So let's see if I can query with country and elevation. So I'm going to put an and elevation. Let's say it needs to be greater than 1000. And I'll hit run. And now we see that our result set has reduced down to 56 documents, which matches this particular query. So now if I scroll a little bit, I can see that these are all the volcanoes in Japan where its elevation is greater than 1000. Now let's go ahead and talk a little bit more about some of the aggregate functions that can be used with the Core SQL API as part of the Cosmos DB. So you can use aggregate functions to summarize data and select queries. So you place aggregate functions in the select clause. The Core SQL API query language supports a couple of aggregate functions like count, sum, average, max, and min. So as you can imagine, count is where the function will return a count of the number of instances a particular field in the result set occurs. Sum will return the sum of all the instances of the field in the result set. Average will return the mean value of all the instances of the field in the result set. So the values typically are numeric. And max and min will typically return either the maximum value of the field or the minimum value of the field from the result set. So if we go back to the Azure portal, let's have a look at how we can use some of these aggregate functions to again query our volcano data. So I'm back in my Data Explorer, and now let's use some of those aggregate functions to query our container. So I'm going to use the count one, and I'm going to try and count all the volcanoes in Japan, for example. So let's see what we can do. We can change the star to count everything in the container from the container. And I'm going to leave the condition as country equals to Japan and just remove the elevation. I'm going to then highlight this, and I'm going to execute the query. And we can see that 111 is returned. Now, that doesn't really look nice, so I'm going to give it an alias. So count as total volcanoes in Japan. Let me just run that query again. And now I get the result back that the total number of volcanoes in Japan is 111. Now let's say we want to use a different aggregate function. Maybe, for example, we want to find the deepest volcano in Japan. And so we can use the max function to do that. So let's do and change this to max. And we want to change this to c.elevation. And we'll change the name as well. So this is going to be deepest volcano in Japan. And the from and where condition statement we can leave as is. So I'm just going to highlight this and execute this. And we see that the deepest volcano in Japan has an elevation of 3,776. And these are just some of the ways that you can use the Core SQL API to execute SQL-like queries against your Cosmos DB database. So Azure Blob Storage supports 3 types of blobs, as we already discussed. So block blobs, page blobs, and append blobs. Now, you typically use page blobs to implement virtual disk storage for your Azure virtual machines, for example. They're optimized to support random read and write operations. Append blobs is more suitable for storing data as it grows in chunks. So if you've got log data or archive data, and block blobs are the best to be used for static data, and so they're the most appropriate type for storage that needs to be holding things like image data or video content, for example. So in an Azure Storage account, to store blobs, you would need to create a container. And so this container will group all your related blobs together so that you can organize the blobs in a hierarchy of folders inside that container. So let's go back to our Azure portal and see how we can create a container and upload a blob, and also see how we can download that blob as well. So now I'm back in my Azure portal, and what I want to do is create a container in my blob storage and then upload an image. So I'm just going to go into my storage account, and I'm going to find that storage account I created earlier. So if I scroll down a little bit, there it is. Now, I'm on the overview page of my storage account, and if I scroll a little bit down, I can see some of the other types of storages under a storage account that you can create. So, for example, containers means blob storage, file shares means Azure file storage, tables is where you can create your Azure table storage, and queues is where you can create Azure queue storage. So I'm just going to click into containers. Now, I don't have a container set up for my blob storage, so I'm going to go and create one. So I'm just going to go add container, and I'm going to give my container a name. So let's say I wanted to upload some image data to this container. So I'm going to call this images, and then I can also define the access level for this container. So if I hover over this drop down, I can see that there's 3 types of access level I can grant to this container. Private access means no anonymous access at all. Blob access means there is anonymous read access that can be granted for blobs only. And if we set this container to have container level access, that means anonymous read access for both the container and the blobs are allowed. So let's actually stick with private. And I'm going to create the container. Now my container has been successfully created, so I'm just going to go into it. And I'm simply going to upload some image data. So I'm going to go upload, and I'm going to go and select a local file from my desktop or folder. And here you go, I've got some image data here. So I'm just going to pick one at random, and I'm going to pick this one. I'm going to open it, and then I'm just going to upload that to my blob storage container. Now that's been uploaded, so I'm just going to close out of this. And because I've set the container to have private access only, which means there won't be any anonymous access at all. So to be able to access this blob, I would need to get some sort of authenticated or authorized access rights to it. So what I can do is actually I can grab a SAS token, which then gives me a time frame or time period with which I get authenticated access to this particular blob if I can present the SAS token. So if I select this and I come into these 3 buttons here, the 3 buttons here actually, and then I can generate a SAS token from this blob. Now, what that means is I can come in here and I can create a shared access signature, so SAS, which will then grant me access to this blob. And so if I scroll down here a little bit, I can assign a couple of permissions. So I can give it read, create, write, delete access. I'm just going to give the read access for now, and I can specify a start and expiry time for when I can actually access this blob. So I'm just going to leave all the default values. I can also choose which protocol to allow, and then I'm just going to hit generate SAS token in URL. And here you go. Now I've got the SAS token, which means if I copy this SAS URL and I go into a new browser, I hit paste and enter, I'm able to grab this particular blob from my storage account. Now let me just close out of this, and I'm going to go back to my container. Now, if you wanted to delete this blob, it's quite simple. We just select the blobs that you want to delete from your blob storage container, and we hit delete. And now because I haven't enabled soft delete, which means when I delete this blob, it's going to be permanent. I can't actually recover it. So I'm just going to go and delete this blob. And there you go. Now my blob has been successfully removed. So you can also use Azure File Storage to store shared files, which means a user that connects to this shared folder or file share can read and write files if they've got the appropriate privileges, that is, in much the same way that they would use a folder on the local machine. Now, to create a file share, we use Azure File Storage under the Azure Storage account, much like the blob storage that we saw earlier. And so let's jump it back into the Azure portal to see how we can create a file share under Azure File Storage. So now I'm going to go back out into my storage account. So the same storage account. And I'm going to scroll down a little bit. And so now instead of containers, I'm going to go over to file shares to create my Azure File Storage. I'm going to open that up. And I can just go and create a file share by going add file share. And I need to give my file share a name. So I'm just going to call this my shared files. Now, I also need to allocate a quota to this file share. So I'm just going to say 1 gigabyte. And I can also select the tiers for this file share. So are the files going to be kept in the cool, hot, or transaction optimized tier or premium tier? So I'm just going to leave the default transaction optimized. And I'm going to come in here and create. And there you go. I've created my Azure file shares. So now that we've created our file share in Azure File Storage, we can use a utility to start copying files over, whether that's from our local desktop or from some other sources. And so we can use a utility tool called AZ Copy to copy files over to our file share in Azure File Storage. So let's head back over to our Azure portal to see how we can do so. So now I'm back in my Azure portal and I've created that file share earlier. So if I scroll down here and have a look, here is my file share called share files that I created earlier. So now what I want to do is I want to generate another SAS or shared access signature token to be able to access that file share so that I can start copying files over. So I'm just going to allow access to files. I'm going to turn all this off. And the resource type, I'm just going to select all of them. Now, for this, I can select a couple of permissions. I'm just going to leave the default one that's already chosen for me. And you can configure the start and expiry date time, but I'm just going to leave the ones as is. And then I'm going to generate that SAS and connection key. And now here you go. I've got my file service SAS URL that I can then copy. And now how I'm going to copy over files is I'm actually going to use the Azure Cloud Shell, which contains the AZ Copy utility that I can use to copy files over to my file share. So to access the Azure Cloud Shell, I simply need to open up the Azure Cloud Shell from here. Now, with the Azure Cloud Shell, it supports both Azure CLI commands as well as Azure PowerShell commands, and you can actually toggle that by changing it over here. But I'm already in the Bash one or the Azure CLI one, so I'm just going to continue using this. Now, I need to first upload a file to my Cloud Shell to then copy over to my file share. So I'm going to come into here, and I'm just going to upload an image from one of the ones that I've got earlier. So I'm just going to pick the one next to the one that I've already used before, and I'm going to open this one up. Okay, so now I just need to execute the AZ Copy utility to copy over this file that is currently sitting in my Azure Cloud Shell over to my file share. So I'm just going to execute AZ Copy. I'm going to copy over that file, which I've forgotten the name of, so I'm just going to go into my upload files and I'm going to have a look at the name for it. So it's called Windows 1.0 WebP. So let me just put that in. Windows 1.0 WebP. And let me just double check that. So Yes, that's correct, because that needs to be important. And then I need to import the file server SAS URL that I copied earlier, because that gives us authenticated access to the file share. So in quotation marks again, I'm going to paste that SAS URL. And now I actually need to make some changes to this SAS URL to specify the file share name as well as the image file to copy over. So I need to actually modify this. So I'm just going to put an end quotation mark here, and I'm going to go up. So this question mark is where the SAS token actually starts. And before that, I need to specify the file share name, which I called shared files, as well as that image that I want to, image file that I want to copy over. So it's called Windows 1.0.webp. And hopefully when I press execute, this is going to then use the AZ copy utility to copy that file from Azure Cloud Shell over to my file share. And now it says the job has been completed. So if I close out of my Azure Cloud Shell, I go back to my file share. I open my shared file share up. And there you go. We see that Windows 1.0 image file has been uploaded to my file share. So this concludes Module 3. I hope you've learned a little bit more about non-relational data services in Azure. So let's go take a 10-minute break. And after the break, we're going to start exploring Module 4. Welcome back from the break. So now we're going to take a look at Module 4, where we're going to explore data analytics solutions in Azure. So first, we're going to take a look at what a modern data warehouse looks like. We're going to then take a look at some of the data ingestion services in Azure. We're also going to explore some of the data storage and processing capabilities in Azure. And finally, we'll wrap up with some Microsoft Power BI. So let's get started with Module 4. Lesson 1. Examine components of a modern data warehouse. So the data from relational and non-relational services is retrieved and formatted by using Azure Data Factory. This process is known as ingestion. The formatted data is then written to Azure Data Lake Storage. Now, Azure Data Lake Storage enables you to store large volumes of data quickly and easily prior to analyzing it. At this point, the data can proceed down two paths. So the data is converted into a normalized format suitable for analysis and can be stored into Azure Synapse Analytics services. Alternatively, you can use Azure Databricks to perform other forms of data preparation. For example, you might need to perform additional data transformations or cleaning to remove anomalies and generally tidy up the data set. You can then store the clean data using Synapse Analytics if you require it. Now, Azure Synapse Services acts as a hub holding this cleaned business data. You can then perform a detailed analysis of the analytics that the data has been cleaned and processed into using Azure Analysis Services. So Azure Analysis Services enables you to dig deeper into the data and generate insights from the information it contains. Then Microsoft Power BI can take this information and use it to generate graphs, charts, and reports. And Power BI can also run ad hoc queries against the data processed by Databricks. Now, a modern data warehouse might contain a mixture of relational and non-relational data, including files, social media streams, and Internet of Things or IoT sensor data. Azure provides a collection of services you can then use to build a data warehouse solution, including Azure Data Factory, Azure Data Lake Storage, Azure Databricks, Azure Synapse Analytics, and Azure Analysis Services. And you can also use tools like Power BI to analyze and visualize the data, generating reports, charts, and dashboards. Now, a typical large-scale business requires a combination of up-to-the-second data and historical information. So the up-to-the-second data might be used to help monitor real-time critical manufacturing processes, for example, where an instant decision is needed to be made. Now, other examples include streams of stock market data where the current prices might be required to make informed split-second buy or sell decisions on the stock market. Historical data is equally important because it gives a business a more stabilized view of the trends and how it's performing over time. So, for example, a manufacturing organization might require information about the volume of sales by product across a month or a quarter or a year to determine whether to continue producing certain items, whether to increase or decrease production according to seasonal fluctuations and all that kind of stuff. So historical data can be used to generate insights to help make those business decisions. Now, historical data are generally batch processed at regular intervals. So they could be based on live sales data that might be captured through a continuous stream, and then we capture them into batches and then submit it to a batch shop to be processed one batch at a time or multiple batches at a time. Now, any modern data warehouse solutions must also be able to provide access to streams of raw data and the process information that is derived from this raw data. Azure Data Factory is a data integration service. So the main purpose of Azure Data Factory is to retrieve data from one or more data sources, convert it into a format that you can then process. So the data sources might contain data in various formats and types. So it could contain a lot of noise that you need to first filter out. So using Azure Data Factory, you can extract out and filter out some of those data so that you can keep the relevant and interesting data and throw out the rest. Now, even the interesting data might not be in a suitable format for processing by some of your other services in your data warehouse solution. And so typically you need to also transform it. For example, your data might contain dates and times that's been formatted in different formats. And so you need to standardize that. You can use Azure Data Factory to transform some of these items into a single uniform structure. And then Azure Data Factory can then write out the ingested data to a data store for subsequent processing. So you typically define the work performed by Azure Data Factory as a pipeline of operations. And this pipeline can run continuously or as data is received from a data source. So you can create these pipelines using the graphical user interface inside Azure Data Factory, or you can write your own code. Now, a data lake is a repository for large quantities of raw data. Because the data is raw and unprocessed, it's very fast to load and update, but the data hasn't been put into a structure suitable for efficient analysis. So you can think of a data lake as a staging point for your ingested data before it's then massaged and converted into a format suitable for performing analytics. Now, the difference between a data warehouse and a data lake storage is that data warehouse stores large quantities of processed data, and a data lake storage stores large quantities of raw data that needs to be processed and converted into a format that supports efficient analysis. Now, Azure Data Lake Storage combines that hierarchical directory structure and file systems of a traditional file system that you might be familiar with the security and scalability features provided by Azure. And so Azure Data Lake Storage is essentially an extension of Azure Blob Storage organized into a near infinite file system. Azure Databricks is an Apache Spark environment running on Azure to provide that big data processing, streaming, and machine learning capabilities. So Apache Spark is a highly efficient data processing engine that can consume and process large amounts of data very, very quickly. So there are a significant amount of Spark libraries you can use to perform tasks like SQL processing, aggregations, or even to build and train your own machine learning models using the data through Azure Databricks. So Azure Databricks provides a graphical user interface where you can define and test your processing step by step before submitting it as a set of batch tasks. So you can create Databricks scripts and query data using languages like R, Python, and Scala. You can also write your Spark code using notebooks. So a notebook contains cells, and each of these cells contains a separate block of code. So when you run a notebook, the code in each cell is then passed to Spark for execution, cell by cell. Now, Azure Databricks also supports structured stream processing. So Databricks can be used to perform computations incrementally. So as your continuous stream of data arrives, we can continuously update results from the continuous stream of data. Azure Synapse Analytics is an analytics engine. So it's designed to process large amounts of data very quickly. Using Synapse Analytics, you can ingest data from external sources. So these external sources could be flat files, Azure Data Lake, or some of your database management systems, and then transform and aggregate this data into a format that's suitable for analytics processing. You can then perform very complex queries over this data and then generate reports, graphs, and charts from the results. Now, reading and transforming data from an external source can take a lot of resources, which is why Azure Synapse Analytics enables you to store the data that you have written and process it locally within the service. So this approach enables you to repeatedly query the same data without the overhead of fetching and converting it each time. So you can also use this data as input to then further your analytical processing using Azure Analysis Services. Azure Analysis Services leverages a massively parallel processing architecture. So this architecture includes control nodes, and it enables you to build tabular models to support your online analytical processing queries. So you can combine data from multiple sources like Azure SQL Database, Azure Synapse Analytics, Azure Data Lake Storage, Azure Cosmos DB, and many other more. And then you can use these data sources to build models that incorporate your business knowledge. So a model is essentially a set of queries and expressions that retrieve data from the various data sources, and that can be then used to generate results. So the results can then be cached in memory for later use, or they can be calculated dynamically or directly from the underlying data sources. Now, Analysis Services includes a graphical designer to help you connect data sources together and define queries that combine, filter, and aggregate data. So you can explore this data from within Analysis Services, or you can use tools like Microsoft Power BI to help visualize the data presented by these models. So Azure Analysis Services has a bit of overlap with Azure Synapse Analytics, but it's actually more suited for processing data on a much smaller scale. So typically we use Azure Analysis Services for small volumes of data, so a couple of terabytes, for example. We also use Azure Analysis Services to correlate multiple sources. It supports high concurrency so that you can have thousands of users connect to it at the same time. It also supports detailed analysis so that you can really drill into your data or use functions from Power BI to be able to get that detailed insight into your data. You can also create very rapid dashboards from your data using Azure Analysis Services. So a lot of scenarios actually benefit from combining the use of Synapse Analytics and Analysis Services together. So let's say you've got a large amount of ingested data that require pre-processing. So typically you would use Synapse Analytics to read this data, manipulate it into a model that contains the business information rather than the large amount of raw data. And then you can use Analysis Services to really investigate and get insights and drill down into some of these business models and information. Now, the scalability of Synapse Analytics also gives Synapse the ability to process, terabytes of data into smaller, succinct data sets that summarizes and aggregates a lot of this data, which you can use Azure Analysis Services to then perform that detailed interrogation of this information. And then you can visualize the results through Power BI. So Azure HD Insight is a big data processing service that provides a platform for technologies such as Spark in an Azure environment. So HD Insight implements a cluster model that distributes processing across a set of computers. And this model is similar to the one used by Synapse Analytics, except the nodes are running Spark processing engine rather than Azure SQL Database. So you can use Azure HD Insight in conjunction with Azure Synapse Analytics. So as well as Spark, HD Insight also supports streaming technologies like Apache Kafka and Apache Hadoop. So Hadoop is an open source framework that breaks large data processing problems down into smaller chunks and distributes them across a cluster of servers, sort of in a similar way that Synapse Analytics operates. Now, Azure HD Insight also supports Apache Hive, which is a SQL-like query facility that you can use within an HD Insight cluster to examine the data that's held in different formats. And then you can use it to create, load, and query external tables in a similar way that you would use Polybase for in Azure Synapse Analytics. Lesson 2, explore data ingestion in Azure. So data ingestion is typically the first part of any data warehousing solution. It's arguably the most important part because if you lose any data at this point, then any resulting information can be inaccurate, could fail to represent the facts that you might be interested in, that you're basing your business decisions on. And so in the big data system, data ingestion has to be fast enough so that you can capture almost all the data that might be relevant and that's heading your way. And so you also need enough compute power to be able to process this data in a timely manner. Now, we can ingest data using Azure Data Factory. So as it ingests the data, Data Factory will clean, transform, and restructure the data before loading it into a repository like a data warehouse. Because once the data is inside a data warehouse, we can analyze it. So we need to ensure that before we load it in, the data is actually ready for those analytics workloads. So Data Factory contains a series of interconnected systems that provides a complete end-to-end platform for data engineers. So you can load static data, but you can also ingest streaming data. Loading data from a stream offers those real-time solutions for data that arrives quickly or that changes rapidly. So using streaming, you can use Azure Data Factory to continuously update the information in the data warehouse with the latest data. We can also ingest data using Polybase. So Polybase is a feature of SQL Server and Azure Synapse Analytics that enables you to run Transact SQL or T-SQL queries that read data from external data sources. So Polybase makes use of these external data sources and makes them appear like tables in a SQL database. So using Polybase, we can read data managed by Hadoop, by Spark, by Azure Blob Storage, and other database systems like Cosmos DB, Oracle, Teradata, and MongoDB. Polybase also enables you to transfer data from an external data source into a table, as well as copy data from an external data source in Azure Synapse Analytics or SQL Server. You can also run queries that join tables in a SQL database with the external data, which enables you to perform analytics that span multiple data sources. We can also ingest data using SQL Server Integration Services. So SQL Server Integration Services, or SSIS, is a platform for building enterprise-level data integration and data transformation solutions. You can use SSIS to solve complex business problems by copying or downloading files, loading data warehouses, cleaning and mining data, and managing SQL database objects and data. Now, SSIS is actually part of Microsoft SQL Server. And so with SSIS, we can extract and transform data from a variety of data sources, such as XML data files, flat files, relational data sources, and then load the data into one or more destinations. You can use the graphical tool that's provided by SSIS to create these solutions without having to write a single line of code. And you can also program extensive integration services, service object models to create packages programmatically and code custom tasks and other package objects as well. So SSIS is typically used as an on-premises utility. However, you can also use Azure Data Factory to run your existing SSIS packages as part of the Data Factory pipeline in Azure. And so this allows you to quickly get started on building your Azure Data Factory pipelines using your existing SSIS packages without having to rewrite some of that transformation logic. Now, Azure Data Factory uses a number of different resources like link services, data sets, and pipelines. So with link services, Data Factory moves data from a data source to a destination. So a link service provides the information needed for Data Factory to connect to a source or a destination. For example, you can use Azure Blob Storage link service to connect the storage account to Data Factory, or the Azure SQL Database link service to connect to a SQL database. A pipeline is a logical grouping of activities that together perform a task. And so the activities in the pipeline define actions to perform on your data. For example, you might use the copy activity to transform data from a source dataset to a destination dataset. You could also include activities that transform the data as it is being transferred, or you might combine the data from multiple sources together. So pipelines don't have to be linear. You can include logic activities that repeatedly perform a series of tasks while some condition is true, using, for example, a for each activity, or follow different processing paths depending on the outcome of previous processing outcome, using an if condition activity. You can run a pipeline manually, or you can arrange it to be run later on using a trigger. A trigger enables you to schedule a pipeline to occur accordingly to a planned schedule. So say, for example, we can trigger a pipeline to run every Saturday night or at repeated intervals. So we can also trigger a pipeline to run every minute or every hour, or when an event occurs. So for example, when a file gets landed into Azure Data Lake Storage, or a blob gets deleted from Azure Blob Storage. Now, data sets in Azure Data Factory represents the data that you want to ingest, so the input data, and store, so the output data. If your data has a structure, a data set specifies how the data is structured. So not all data sets are structured. Blobs held in Azure Blob Storage, for example, are unstructured data. And so a data set connects to an input or an output using a link service. For example, if you're reading and processing data from Azure Blob Storage, you create an input data set that uses a Blob Storage linked service to specify the details of the storage account. The data set will specify which blob to ingest and the format of the information in the blob. So is it binary? Is it JSON? Is it delimited text? If you're using Azure Data Factory to store data in the table in a SQL database, for example, you would then define an output data set that uses the SQL database link service to connect to that database and specify which table to use in that database to output the data to. Lesson 3, exploring data storage and processing in Azure. So data lives in many locations throughout an organization. When you design your cloud data solution, you'll want to ingest your raw data into a data store for analysis. So a common approach that you can use with Azure Synapse Analytics is to extract the data from where it's currently stored, load this data into an analytical data store, and then transform the data and shaping it so that it's ready for analysis. Now, Azure Synapse Analytics is particularly suitable for this approach. Using Apache Spark and automated pipelines, Synapse Analytics can run parallel processing tasks across a massive data set and perform big data analytics. Remember, the term big data here refers to data that is too large or too complex for traditional database systems. So systems that process big data need to perform rapid data ingestion as well as processing, which means they need to have the capacity to store the results as well as sufficient compute power to perform those analytics over the results. Now, Azure Databricks, as I mentioned, is an analytics platform that's been optimized for Azure. So Azure Databricks was actually designed by some of the founders of Apache Spark. So Databricks is integrated with Azure to provide a one-click setup so that we can streamline the workflows and provide an interactive workspace that enables collaboration between data scientists, data engineers, and business analysts. So with Databricks, we can process data held in a lot of different types of storage, including Azure Blob Storage, Data Lake Storage, Hadoop Storage, flat files, databases, and data warehouses. Databricks can also process streaming data. So Databricks uses an extensible architecture that's based on drivers to do so. The processing engine is provided by Apache Spark. So Spark is a parallel processing engine that supports large-scale analytics. So you typically write application code that consumes data from one or more sources and merge, reformat, and filter and remodel this data, and then store the results. So Spark distributes the work across a cluster of computers, and each of the computer can then process its data in parallel with other computers. And so this would actually reduce the time required to perform the work. And so Spark is designed to handle massive quantities of data. You can write your Spark application code using a couple languages. So Spark supports Python, R, Scala, Java, and SQL. Spark also has a number of libraries for these languages, and some of these libraries includes modules for machine learning, statistical analysis, linear and non-linear modeling, predictive analytics, and graphics, so that it can support complex analytics tasks as well as optimizing your workload for a cluster environment. Now, you typically design your application or write your Databricks applications using a notebook. So again, a notebook would contain a series of cells. Each cell will contain a block of code. So for example, one cell might contain code that connects to a data source. The next cell will then read the data from this source, convert it into a model in memory, and then the cell after that could plot a graph. And the final cell after that could then save the data from the in-memory model to a repository. Now, Azure Synapse Analytics is made up of a couple of components. So there is the Synapse SQL pool, there is the Synapse Spark pool, there are Synapse pipelines, Synapse Link, as well as the Synapse Studio. So with Synapse SQL pool, this is a collection of servers running Transact SQL or TSQL. So Transact SQL, if you remember, is a dialect of SQL that's used by Azure SQL database as well as Microsoft SQL Server. So you can typically write your data processing logic using TSQL and execute it on a Synapse SQL pool. Now, Synapse Spark pool is a cluster of servers running Apache Spark to process data. So you can write your data processing logic using either Python, Scala, SQL, or C#. So C# has in .NET there is libraries which support Apache Spark. So Spark pools can also support Azure Machine Learning through integration with Spark ML or Azure ML packages. Now, Synapse Pipeline is a logical grouping of activities that together perform a task. So the activities in the pipeline define actions to perform on your data. So for example, you might use a copy activity to transform data from a source data set to a destination data set. You could include activities that transform the data as it is transferred, or you might combine the data from multiple data sources together as part of the pipeline. Now, Azure Synapse Link is a component that allows you to connect to some of the other Azure services like Cosmos DB, for example, so that you can use it to perform near real-time analytics over operational data that's stored inside a Cosmos DB database. And Azure Synapse Studio is a web user interface that enables data engineers to access all these Synapse analytics tools. So you can use Synapse Studio to create your Spark or SQL pools. You can use Synapse Studio to define and run your Synapse pipelines, or you can use the Synapse Studio to configure links to some of your external data sources.
Now let's have a look at a demo where we load data into an Azure Synapse Analytics. So imagine that you're part of a team that is analyzing house price data. So the data set that you receive contains house price information for several regions, and your team might need to report on how the house prices in each of those regions vary over the last couple of months. So to achieve this, we can ingest the data into Azure Synapse Analytics, and we would use Azure Data Factory to perform this task. So let me just jump into my Azure portal to show you how we go about this. Now that I'm back in my Azure portal, the first thing I want to create is a storage account. So I'm just going to look up storage account, and let me just create a storage account. I'm going to put it into my demo resource group. There you go. And I'm going to call this housing storage account. That's pretty unique. I am going to put it into the East US Azure region, and I'm going to leave most of the default. I'm going to change it to locally redundant storage, and I'm just going to go review and create, because what I really want to create is an Azure file storage in my storage account. So I'm going to go create. Now, while my storage account is being created, I'm going to go and also set up a Synapse Analytics. So I'm going to look up Synapse, and I'm going to select Azure Synapse Analytics, the Workspaces preview. I'm going to go hit Add. And again, I need to provide some basic credentials, so I'm going to put it into the demo resource group. Now I need to give my Synapse Analytics a name, so I'm just going to call this Demo Synapse Analytics. That checks out. I'm going to put it into the East US region again, and now I need to create a data lake storage because I don't have one. So I'm going to go create new. I'm going to call this Demo Data Lake. Oh, someone's taken that. So Data Lake Housing. There we go. Now I also need to give it a file system name. So I'm just going to create a new one. Let's call it logs. I can also assign myself the storage blob data contributor on the data lake storage Gen 2 account. So I'm going to check that. Now I can go into security, and I need to provide it some SQL administrator credentials. So would recommend changing this default admin username, but I'm just going to leave the default and put in a password. Again, I'm going to repeat that password. I'm just going to hit next. and you can configure to allow connections from all IP addresses or disable it from here. I'm going to skip tags. I'm going to go into summary, and then I'm just going to hit create. Now, while our Synapse Analytics is being created, let's check on our deployment from our storage account. So our storage account has created. Let's go to that resource. So let me just go back to that resource. There we go. Now I'm going to scroll on the left here, and I'm going to go find file storage. So file services, and then under file shares, what I'm going to do is create a new file share, and I'm going to just call this file share housing. I'm going to allocate it some quota, select the hot tier. I'm going to go create. Now my file share has been created. I'm going to go into my file share, and I'm just going to upload a file I have on my local PC. So I'm going to upload files, select the file. There we go. I'm going to select the CSV file, and then I'm going to go upload. And now it's been uploaded. So it looks like our Synapse Analytics is still being created. So why don't we use this time to go create a data factory? So I'm going to look up data factories, and I'm going to go add. Now I'm going to use my internal subscription, put it into my demo resource group. Then I'm going to pick that same region I used earlier for the other two resources, so SUS. I'm going to give my data factory a name. So I'm going to call this demo ADF, for example. Oh, that's not available. Okay. ADF demo. Let's call it housing as well. And you can select between two versions for Data Factory. Obviously, version 2 is the latest version, so I'm just going to leave it as this. Now I'm going to go to next for Git configuration. So you can configure your repository to be either Azure DevOps or GitHub for version control. I'm going to do the setup later, so I'm just going to tick the configure Git later box. Go to networking. Again, you can select your connectivity method. I'm going to leave the public endpoint for now. I'm going to skip tags and just go review and create. So create that. And let's check on our Synapse Analytics. So if I go to that resource group called demo, I can find all the resources that I've just created. So let me filter by name. And there you go. So I've got my storage account, my Synapse workspace, and so the data lake that I created, data lake storage and the storage account and the Synapse Analytics workspace. So let me just go into the Synapse Analytics workspace. So it says the resource is being provisioned at the moment, which is fine because I have actually set one up before this so that we don't have to wait. So let me go and find the one that I set up before. It's under the DP900 resource group. And I'm going to scroll a little bit to find that Synapse Analytics workspace. There you go. Now this one's called the My DP900 Synapse. And what I'm going to do is I'm going to scroll down on the overview page a little bit and open that Synapse Studio. So once provisioned, this is what we want to open up. So the Synapse Analytics Workspace Studio. And from the left-hand side, I can access my data. And I've set up one database in my SQL pool. So let's have a look. I've called it my Synapse SQL. And inside this database, I have one table at the moment called housing data. So that's what we want to set up in our Synapse Analytics that we are currently deploying. So let's just go check out how the progress is. Again, I'm going to go back into my resource group and go find my Synapse Analytics. It looks like our Synapse Analytics has been provisioned now, just then. So What I'm going to do is from here, go add a new SQL pool. And I need to create a SQL pool. So I'm going to give my SQL pool a name. So demo SQL pool. I'm going to scale this right down just because it's a demo, but you can, increase the performance level as you need. Now I'm going to go to additional settings. I can configure what data source to set up my SQL pool. I'm going to choose none, and I'm just going to skip tags and go straight to review and create. And I'm just going to create that. Now again, that's going to take a couple of moments to provision. So once that's provisioned, I'm going to open up the Synapse Analytics workspace, and from there, I'm going to create that table called housing data, so that I can eventually ingest my data stored in that file share into my Synapse Analytics. So our SQL pool just finished being deployed. So let's go to our Synapse Analytics workspace. I'm going to click Go to Resource, and from here, I'm going to go and open up the Synapse Studio. Now, once our Synapse Studio Analytics workspace has opened up, let's go into the Data section and open up Databases. And we can see that demo SQL pool that we had just created. So what I want to do is I actually want to go and create a table. So I'm going to go to New SQL script, an empty script. And what I want to do is I actually want to execute a table on this database. So I'm going to go create a table. I'm going to enter this predefined script that I had earlier. So this is going to create that housing data table with fields like geo name, month, average price, etc. And I'm just going to hit run. So we can see the query being executed here. It took, 3 milliseconds to execute successfully. Now, our table is now inside our SQL pool database. So we can see it here. So now I'm going to go back to my Azure portal, and I am going to now search for my data factory that I had created earlier. There we go. ADF demo housing is the data factory I had just created live. I'm going to go into this, and from here, I'm going to go and click into author and monitor. This is going to open up my Azure Data Factory for me. Now, from my Azure Data Factory, I can create pipelines, I can create data flows, I can create pipelines from a template, I can copy data, I can configure SSIS integration or set up code repository. So I'm going to copy data, and I need to specify a couple of things. So I'm going to call this my demo copied pipeline. I can give it a description, and I'm just going to select run once now, hit next. Now I need to create a source data store. So I'm going to create a new connection, and I'm going to look up the file storage where I've uploaded my housing data as a file. I'm going to hit continue, and I'm just going to call this my Azure file storage. I can give it a description. So I'm going to use the integration runtime, and the way that I'm going to access it is I'm going to use the user connection string. So from the Azure subscription, I need to pick my internal subscription. There you go. And I need to find that storage account name. So I believe I called it housing storage account, and that's going to load that key. I'm going to find that file share, so called housing, and then I can go create. And that's going to create a connection to my Azure file storage. Now I'm going to go next. And then I'm going to go and find that file in my file share. So I'm going to go browse. And there you go, houseprices.csv. I'm going to choose that. Now, we can configure other settings, but I'm just going to leave them for now and go next. And now I just specify the file format settings. So it's going to be text format. There's other formats that it supports. Because it's a CSV file, it's going to be a comma column delimiter. And I can configure other things, so I'm just going to go next. We get to see a little preview of what that data looks like. Now I need to configure a destination data store. So the destination is going to be our Synapse. So I'm going to go create a new connection, and I'm going to look up my Synapse that I had just created. There we go, Synapse Analytics, and continue. Now I'm going to call this my Azure Synapse Analytics. Again, I can give it a description. I need to connect to my Synapse. So let's just look up the instance I created. So I called it Demo Synapse Analytics, and the database is that demoed SQL pool. Now I also need to authenticate to it. So I'm going to call this, I'm going to authenticate to it and give it the password. And then I can test connection here just to check that it is successful to connect to my Synapse Analytics. I'm going to hit create. And now I've created a connection to my Azure Synapse Analytics. So I'm just going to hit next. Okay, so now I need to map my, essentially my CSV data to my Synapse Analytics. So let's see if we can use existing table. And I'm going to select housing data. So this is the one that I want to map the files in my Azure File Storage to the housing data table in my Azure Synapse Analytics. Going to go next. And we can see some of that column mappings. So everything in my housing data file is specified as a string type, and then everything in my Azure Synapse Analytics table that has its own type. So varchar, char, int, and int for the remaining columns. I can also specify a pre-copy script and other settings as well, but I'm just going to leave that for now and go next. Here I can, for example, enable staging, configure fault tolerance, and specify the copy method like polybase, copy command, or bulk insert. I'm going to select bulk insert, and I'm going to disable staging for now. And I can also specify the degree of copy parallelism. And here we can also specify the data integration unit. So for now it's auto, so it's going to be automatically detected, but we can also manually pick one of these for our data integration units. I'm just going to leave it as auto, and I'm going to go next. Finally, this is a summary of the copying process from Azure File Storage to our Azure Synapse Analytics. So once we review this, we just go next. And that is going to start that copying process. So we're validating it, creating data sets, creating pipelines, and now we're running that pipeline. And it looks like we've just finished. So let's just hit finish. And we go back to our Synapse Analytics workspace here. So now what I want to do is I just want to hit a little refresh. So let's do refresh. And then this data should be copied into our demo SQL pool database table. So the housing data table. So I'm just going to drill into the table. And then from here, I'm just going to, let's check out the top 100 rows to see if the data has been successfully copied over. And there you go. We see that the data is now in our housing data table.
Lesson 4, getting started with building Power BI. So Microsoft Power BI is a collection of software services, apps, and connectors that work together to turn your unrelated sources of data into coherent, visually immersive, and interactive insights. So whether your data is simply held inside an Excel spreadsheet, or it's data that's inside either a cloud-based or on-premises data warehouse, Power BI allows you to easily connect to any one of your data sources and visualize or discover what's inside the data and share that with anyone who wants it. So Power BI can be a very simple and fast way to create quick insights from your Excel spreadsheets or local database, or it could be used to create robust and enterprise-grade models that support real-time analytics. So you can use Power BI to create, personal reports and visualization, but it can also serve as an analytics and decision engine behind group projects, divisions, or an entire organization. So Power BI consists of a couple of components. So there is the Power BI desktop and the Power BI servers, as well as Power BI mobile app. So the Power BI desktop is a Microsoft Windows desktop application. Power BI Service is an online SaaS, software as a service, and the Power BI mobile app is essentially a mobile app that runs on either Windows, iOS, or Android mobile operating systems. So each of these three elements, so desktop, service, and mobile apps, are designed to let people create, share, and consume business insights in the way that serves them the best. So for example, you might be a user who view reports and dashboards in Power BI service, or you might be the one who are creating those number crunching business reports through Power BI desktop, and then publishing those reports to either Power BI service or the Power BI mobile app so that other users can view and consume and use them. So that, one of your colleagues, say for example, in sales might then use the Power BI mobile app to then monitor the progress of, say for example, their sales quota and drill into new sales leads and all that kind of stuff. Now, Power BI generally follows a common flow. So the common flow of activities looks something like this. So you might bring data into Power BI desktop and create a report. Then you publish to the Power BI servers where you can then create a new visualization or build dashboards from. And then you can share these dashboards with other people, typically through either the Power BI mobile app, so that people can actually, or users can actually view and interact with these shared dashboards and reports. So as a Power BI user, you might spend all your time in the Power BI servers viewing the visuals and reports that's been made by others. Or you might be a user that spends all their time in Power BI desktop creating and building those reports out as well. Or you could be a user that only interacts with the Power BI mobile app to get those insights and drill down into some of the information presented by some of the results that's been visualized or created into a report through Power BI. Now, everything you do in Microsoft Power BI can be broken down into a few basic building blocks. So these building blocks are visualizations, data sets, reports, dashboards, and tiles. So a visualization, also called a visual, is a visual representation of data, like a chart, or a color-coded map, or any other interesting things that you can create to visually represent your data. So Power BI has all sorts of visualization types that you can use. Now, visualizations can be quite simple, so it could be a single digit number or a single number that represents something significant, or they could be quite visually complex, like a gradient colored map that shows voter sentiments about a certain social issue or concern. The main goal of a visual is really to present data in the way that provides context, insights, both that could otherwise be quite difficult to gather from a raw table of numbers or text. Now, data sets is a collection of data that Power BI uses to create its visualizations. So you can have a simple data set that's based on a single table from Microsoft Excel spreadsheet. Data sets can also be a combination of many different sources, so which you can filter and combine to provide a unique collection of data or a data set for use in Power BI. So for example, you can create a data set from 3 database fields, for example, one website table, an Excel table, and some online results through maybe a marketing campaign through email. So combining all these data sources into one data source in Power BI is considered a single data set. Now, in Power BI, you can also create a report, which is a collection of visualizations that appear together on the same page or pages. And just like any report that you might have ever created, either for a sales pitch or for a school assignment, a report in Power BI is simply a collection of items that relate to one another. And so reports lets you create many visualizations, either in a single page or multiple pages, and it lets you arrange those visualizations in whatever way that you think would best tell a story with the data and with the information and insights that you've gathered. And so you might have a report about quarterly sales. You might have a report about product growth in a particular area. You can even create a report on the migration of polar bear patterns if you wanted to. So whatever subject that you need to create a report on, Power BI allows you to gather and organize all your visualizations into one or more pages. Now, with dashboards, when you're ready to create to share a single page from a report or a collection of visualizations, you can create a dashboard to do so. So a dashboard is very similar to a dashboard that you might have seen in a car, for example. So a Power BI dashboard is a collection of visuals from a single page that you can then share with others. And often it's selected groups of visuals that provide very quick insights into the data or the story that you're trying to present with the data. And so a dashboard must fit into a single page. Often this is called a canvas. So a canvas is essentially a blank backdrop in Power BI desktop or servers where you can put visualizations onto. So you can think of it like the same canvas that an artist or a painter might use to create their art or paint. So a dashboard is that workspace where you can create and combine and rework some of those very interesting and compelling visuals and put together a story into a sort of single page dashboard that you can then share with others so that they can view and interact with it, either through the Power BI servers or through the Power BI mobile app. Now, tiles is in Power BI a single visualization on a report or a dashboard. So it's typically a rectangular box that holds an individual visual. So when you're creating a report or dashboard in Power BI, you can move or arrange the tiles however you want. You can make them bigger, you can change the height or the width. You can sort of group them with other tiles if you wanted to. Now, when you're viewing or you're consuming either a dashboard or a report, which means you're not typically the creator or the owner of that particular report or dashboard, but someone has actually created it and shared it with you, you can interact with it, but you can't typically change the format of some of these tiles. So you can't change the size of the tiles or the arrangement of these tiles. So just to sum it up, Power BI is a collection of services, apps, and connectors that lets you connect to your data wherever it might happen to reside. And you can do some filtering if necessary, and you can then bring it into your Power BI to create those compelling visualizations and dashboards and reports and story with your data that you can then share with others. So for some people, using a single Excel spreadsheet or table and a data set, and then sharing that through a dashboard with the team could be, one way to use Power BI. For others, the value of Power BI might be actually using that, using real-time Azure SQL database tables, combining that with other databases and real-time sources, and building that sort of moment-by-moment data set. And so whatever group you might fit into, the process is the same. We can use Power BI to create data sets, to build compelling visuals, and share it with others. And the result is also the same for both groups. So you can really harness the ever-expanding world of data and turn it into actionable insights. So whether your data insights require straightforward or complex data sets, Power BI supports that, and Power BI can help you very quickly get started and expand as your needs and your scope expands, and as that complexity in your data expands as well. And because Power BI is a Microsoft product, you can count on the fact that it's a robust, extensible, and Microsoft-friendly product that is enterprise ready. Wow, so this concludes the training for Microsoft Virtual Training Day for Data Fundamentals. So let's have a look at everything we've covered in this training. We started with Module 1, where we covered core data concepts. Then we had a look at Module 2, which explored relational data in Azure. And then we had a look at Module 3, where we explored non-relational data in Azure, as well as Module 4, where we had a look at some of the data analytics solutions in Azure. So thank you for taking part in both Part 1 and Part 2 of this Microsoft Azure Virtual Training Day for Data Fundamentals. Now, just remember, you can continue your learning journey. We have a great variety of resources, such as the Microsoft Learn platform, where we offer self-paced learning paths for you to take your learning journey further. So I wish you all the best for your exams and happy studying.